morning. This is Introduction to Algebra for Thursday, April the 2nd. We're going to be looking at lesson 100 for today. We're going to talk about the distributive property. Now, the distributive property, it means simply distribution, okay? So, if we have normally, when we work this problem, 4 parentheses 2 plus 3, you and I would normally say, oh, well, we're going to add what's in the parentheses and get 5 and say 4 times 5 is 20. And that is correct, okay? But if I want to show the distributive property, what I'm really doing is I am multiplying 4 times 2, then I am multiplying 4 times 3. So I would say 4 times 2 plus 4 times 3. Okay, so 4 times 2 is 8, and 4 times 3 is 12, so my final answer is still 20. The only difference in the two answers is the fact that the second one is using the distributive property. I'm showing you how I'm breaking it down. Okay, let's look at this problem here. We have 4 parentheses x plus y. Now, I cannot work this problem the way I did this one above. Okay, because here I added my 2 and 3 and then I multiplied. Well, I cannot add x and y because I don't know their value. So what I have to use is the distributive property and say 4 times x is 4x plus 4 times y is 4y. So the answer to this 4 parentheses x plus y is actually 4x plus 4y. Now, let's look at another one. Here's another distributive property. Let's try it. It's just a little longer. It's not any different. What if I have 4 parentheses, x plus 2y minus 8 parentheses, and I want to use the distributive property? I'm going to multiply 4 by each term that's inside the parentheses. So 4 times x is 4x. 4 times 2y is 8y. And then 4 times 8 is, we're going to minus 32. Okay? So, let's try the one up here. We have 3x times, parentheses, or 2 plus x squared, parentheses. Okay? So, if I have 3x times 2, okay, what am I going to have? I'm going to have 6x. All I'm going to do is take my 2 coefficients, my 3 and my 2, and multiply them and get 6. Now, when I look at the next one, I have 3x plus x squared. Now, there is no coefficient here, so we know that it's really the number 1. So 1 times 3 is 3. Now, what about the x's? When you multiply something that has a power, what do you do to the powers? You add them, okay? So, x times x squared is x cubed, okay? Let's try another one. What if we have 4 parentheses 3x squared plus 2x parentheses, okay? Let's work it out. What are we gonna say? We're gonna say 4 times 3, that's our coefficient, and get 12x squared, okay? Plus 4 times 2 is 8, and the only letter is an x. Let's go down here. We have x, we're gonna multiply, then we're gonna parentheses negative x squared minus x minus 4. So we have to think this through, okay? This x is inside the parentheses, this negative sign, so we're gonna say x times negative x squared, okay? And we're gonna have what? Negative x cubed, because we have 1x here and 2 here, and we add the powers. Now we have x times negative x is gonna give us a negative x squared or minus x squared. X times negative 4 is gonna give us a negative 4x. So our answer is negative x cubed minus x squared minus 4x, okay? This is all there is to the distributive property. You simply take the coefficient and multiply it by each thing inside. If it has in this case, our term of 3x, we're going to say 3x times 2. I'm going to multiply the coefficients, and I'm going to keep the x. Here I have an x that's squared, so I am going to multiply my coefficient of 3 and 1 and get 3. Take my x and my x squared, and I get 3x. That is all there is to the distributive property. Now, we can also today, I want you to look in your book, please, at page 292. We've already done the practice problems at the top that I was wanting you to do today. We've already done them, and I do understand that there are two concepts in the lesson. We'll come back to the other one. I want you to look at number 1. The football coach shuddered when he realized that the ratio of dexterous to impet were 3 to 7. 3 to 7. If 140 players were trying to make the team, how many were dexterous? Now, 140 is a what? It's the total, okay? So we have to think about, we're comparing here. So what do we have? We have 3 to 7 is our ratio of players to other players, okay? We have 3 to 7, but what's my total? My total is 10, okay? So I have to look back here. The 3 is going to be our dexterous. All right, now we have a total of 140. So what ratio am I going to look? Well, look at what you're looking for. How many were dexterous, okay? So I don't care about this. So I'm going to say there were 3 to 10. And that's going to equal the total of 140 players. I believe is the number our book gave us, 140. Okay, so we're going to put an x, and all we're going to do is cross multiply. 10 times x is 10x. 3 times 140. 3 times 4 is 12. 3 times 1 plus 1 is 4. So our equation is 10x equals 420. Now, all I did was cross multiply. Okay, I'm going to divide by 10. This is going to cancel, giving me x equals 42. Now, let's go back and make sure we all understand. We said our 3 were dexterous and 7 were epit. Okay, that gives us a total of 10. Now, I want to compare the total of 140, so I need a total on this side, which we said was 10, and then we're not going to use these, so we used the 3, and we simply cross multiply. I hope that was a good review there for that type of problem, implied ratios. When the score was announced, 420 students were elated, and the rest were dejected. If the ratio of elated to dejected was 2 to 9, how many students were there in awe? Okay, well, we know that we have to look at our ratio. Okay, so let's make our ratio. Let's get all of the information that we have. We know here, first of all, we have a ratio of 2 to 9. Okay, these are our elated students. And these are the dejected students, the ones that did not do well. Okay, so in our ratio, we have a total in our ratio of 11. That's our total. Now let's go back and see what the information gives us so we can decide how to use this information. When the score was announced, 420 students were elated. Okay, 420 were elated. The rest were dejected. If the ratio of elated to dejected was 2 to 9, how many students were there in all? Now let's think about this for a second. We know that there are 2 elated, there are 9 dejected, there are total for this is 11. So how are we going to set this up? Well, we have to compare because our total that we know is the elated. So we're going to say 2 to 11 equals. Now, think for a second. Go back to your story problem. It says that 420 of the students are elated. That's a total number of what? The total number of elated students. So the total number here has to be our elated. This is the total number in all, because we don't know what the all total is. We know the total of this ratio, but we don't know the total of the whole thing. That's why we're putting it there. Okay? Let's change this to an x, though, not a t. Okay? So 2 times x is 2x. Now we're going to say 420, because, we're going to cross multiply. We're going to say 420 times 11. 420 times 11 is 4,620. Now all I'm going to need to do is divide by 2. This cancels, leaving us x. Goes in here 2 times, 3, 1, and 0. So it's a total of 2,310 altogether. Let's look at number 3. When Lafayette led the column, the troops marched 24 miles in 6 hours. He left the troops reduce their speed by 1 mile per hour. How long did it take them to march the last 18 hours? The last 18 miles, okay? Well, first we have to set up our ratio of rate. We have to look at our rate problem, okay? So according to our story problem, they were going 24 miles in 6 hours. Okay? So then they reduced their rate by 1 mile per hour. Okay? So if he reduces it 1 mile per hour, okay? He's going to reduce their rate 1 mile per hour. Now, how fast is he going? Okay? So we have to figure that out. So the best way to do that is to say, okay, well, this is going to, I like doing it this way, guys. Okay? I like reducing it first to say that 6 goes into 24, 4 to give us 4 miles per hour. I just think it makes it a little easier to do. Okay, now he's going to reduce it 1 mile per hour, giving us 3 miles per hour. That's how fast they're going now after he reduced it. Look back at your story problem. It says at this rate, he wants to know how long it's going to take him to do the last 18 miles, okay? Now, I'm looking for time. So I'm going to say 1 hour. We're going to do 3 miles. Now, why am I doing that? Why did I change my ratio? Because over here, I'm going to multiply this by the number of miles. And I want my units to cancel because I want my unit to be in hours. So this is going to cancel. And I'm going to say, I'm going to cancel this, put 1, cancel this and make it a 6. So 1 times 6 is 6. It's going to take them 6 hours at that speed to do the last 18 miles. All right, that is all for our lesson today. I hope you have a great day. Please make sure you're doing your homework and your quizzes. I'm going to try to send grades out to you, and I really want them to look good for your parents. Okay, I don't want them to, be all upset with you because you're not doing your work. Okay, I'm really proud. 8th grade, you're really, really doing well. Okay, have a good day.